On this part of chemistry, we are going to talk about solubility and colligative properties of solutions. Okay, if we have here water, and in this water just we put a cube of sugar into this water. The cube of water will be dissolved inside the water. So this process that we call it solvation process now, when the cube becomes here, how it gets dissolved? Because now, this one now, as you see, this cube, we call it solute. We call it what? Solute. And the water molecules, we call them what? Solvent. And the process of solvation, that means that the molecules of the solvent will surround the solute molecules, and they'll be combined, then they means they'll be united as molecules and molecules. So in this case now, the molecules of solvent, of the solute will be what? Distributed throughout the solvent molecules. So this process, we call it what? Solvation. So that means it's the process of surrounding solute particles or molecules by the solvent particles. Okay, this process now, how can we increase the rate of solubility here? How can we increase it? That means now this cube of sugar, how much time it's going to take in order to be dissolved completely? And how can we increase that amount of time? How can we decrease that amount of time or increase it? How? So first, to increase the rate of solubility, that means to get less time for this cube of sugar to be dissolved in less time. One of them to get less time is to stir this solution. So that means by stirring, you get less time of solvation rate. Okay, number two, we heat it. So that means we increase the temperature. If we increase the temperature, then that means solubility will be less, will take less time. Okay, number three, we increase the surface area. How increase the surface area? For example, now this cube of sugar if we divide it into two parts, we divide it into two parts. This cube, we divide it into two parts. Did we increase the surface area or we decreased it? If we divide it, that means now look, when it was just a cube, as we know, the cube has 6 faces, right? Up, down, left, right, front, back. So it has 6 faces, right? If we divide it into 2 parts, that means we will we'll get 2 faces more. We'll get 2 faces more. So that means the surface area now, when you divide things into smaller parts, the surface area is increased. So that means when you put now this cube as 2 parts here, the solvent molecules will surround this part and will surround this part. So that means more ability or more surface area that solvent particles can attack or can go to the solute particles. So if we increase also the surface area between the contact in the contact surface between the molecules of solute and the molecules of solvent, in this case we increase the rate of solubility. So that means we can increase it either by increasing the temperature or just by increasing the surface area or by stirring. So this is now solubility, how can we increase it? Okay, if we have here water, like liquid or juice or whatever, is it liquid? And we want to put gas into it. That means we want to dissolve gas into this liquid. And it happens in our real life. Like, for example, soda, as we know, we put carbon dioxide, which is CO2, on it. And it is the responsible gas. When you open the soda, you hear a sound there because there is carbon dioxide inside it. This carbon dioxide now, when you put it inside, that means we dissolve the gas inside the liquid. How can we increase the solubility of gas inside the liquid? By two things, either by increasing the pressure of the gas on that liquid or by decreasing the temperature, or by both. And we have Henry's law that says at a constant temperature, related, if we study two quantities, we have to make one of them stationary. So if we make the temperature constant, what will happen between the pressure of gas and the solubility? Will both be directly proportional or inversely proportional? Henry's law says at a constant temperature, increasing the pressure of the gas will increase or will be directly proportional to the solubility. And that one here, we can combine that law by the solubility 1 over pressure of gas 1 equals solubility 2 over pressure of gas what? 2, and this one is called Henry's law. If the question here comes, they give you 3 quantities and they ask you about the fourth one. If one, for example, here, if the solubility of the first one, the first solubility, for example, was 2, and here the pressure was 3, when the same units, and here they give you 5. So this one will be what? Variable. So you solve as math to find the fourth what? Variable. So you understand now solubility, we understand how to increase the solubility rate, and we understand what is Henry's law and how we dissolve or increase the solubility of gases and liquids. And this is the first part of the lesson today. What is the second part? The second part is colligative properties of solutions. Colligative properties of what? Of solutions. What is colligative properties of solutions? What is colligative properties of solutions? Okay, look here now. And what does it mean, or how do we use it? And why do we study it? Okay, if we have here water, and this one now is the amount of water here. And here now is also water, and this one is the amount of water. Okay, both of them, for example, is 500 milliliter, and here 500 milliliter of water in both containers. Okay, as we know, freezing point for water in general, it's gonna be 0 Celsius, 0 Celsius, and boiling point, temperature of boiling point is what? Is 100 Celsius. Okay, now water in this case now, as you see, it's water. Just we don't have any other materials. We don't have any other material in it. So if we add here, this one, we're gonna leave it water as it is. But here in the other part here, we're gonna add salt. We're gonna add particles of salt or sugar to it. The question is, what would happen? As you see, this one now becomes solution. This one becomes solution, while this one now is still just solvent, which is water alone. But here it becomes sugar and water, right? So that means we have solute, which is sugar, and solvent that are water. So this one now becomes what? Solution. The question now, in this solution, where there is the solvent, the water, and also another solute particles, will the boiling point of water and the freezing point, will it keep being the same as it was there, here? Will it keep being the same number, 0 Celsius, freezing point, and boiling point will be 100 Celsius? Or what would happen? So this is now what's in colligative properties. So colligative properties of solutions. Of what? Of solutions. So that means colligative properties of solutions, it means what will be changed in solutions compared to their original or pure solvent. So this one is water, and here is water as well, but water here is just solvent, a pure solvent, but here it is solvent with other solute. So now what will happen? What will be changed for solutions compared to what? To their original pure solvent. So this solution now, we're going to see that the temperature of freezing point, what will happen to it? It will decrease. So that means it's going to be less than 0 Celsius. Okay, what about boiling point here? Boiling point, it will increase. And this one now This one now is properties of solutions. So we need, this is now common. So that means if you have solvent alone, water or any other solvent, if you add to it particles, it's going to be solution. And this solution now compared to the pure solvent, temperature, freezing temperature will decrease. That means it's going to be less than the solvent freezing point, and boiling point will increase. That means it's going to be more than the boiling point of the pure solvent. Okay, what are colligative properties? Here we have 4. Number 1, freezing point will decrease. Boiling point will increase. So these ones now 2 properties. What is the third one? The third one, vapor pressure will increase. Vapor pressure will decrease. Okay, so that means this is number 3. This is here 1, and here is 2, and here is number 3. Is vapor what? Vapor pressure in solutions will decrease, and we're going to explain it in details. Okay, number 4 now, this solution will have osmotic pressure. The solution will have osmotic pressure. So that means you need to remember these 4. Colligative properties of solutions are 4. Temperature, related to boiling point, it will increase. Related to freezing point, it will decrease. And vapor pressure will decrease as well. And this solution will have osmotic pressure. Okay, now we're going to explain what's vapor pressure and how it is changed in solutions. Okay, if we have a container here of water, a container of water, and this container here, for example, is closed. As we know, some particles of water will be here evaporate as gas. And these ones now, they'll make what? Pressure. They'll make pressure either to the walls or to next to each other. They're going to have pressure, and this pressure is called vapor pressure. So that means it's the pressure of molecules that are turned into gases. Okay, what about now if I have water and we said, but this water is with sugar inside it, right? Here now we'll have also particles here up as gas, and these ones, they'll have what? Vapor pressure. And this vapor pressure in solutions here and here, so this one here is going to be less. Why less? Because now keep that in mind, vapor pressure decreases as number of solute particles increases. Okay, here now, as we see here, that means it was all of it solvent 100%, and here there were no solute. Solute was what? 0%. So that means here vapor pressure is maximum. Vapor pressure is what? Is maximum. While on the right side, as we know here, that means this part now will be solution. That means here maybe 90% now of it is solvent, right? But now we'll have around 10% what? Solute inside this solution. That means now the solute is increased. Look, on the previous one it was 0 here. Now it is what? 10% solute. So that means number of solute particles increase. So that means vapor pressure will what? Will decrease. So that means in solutions, since the pure solvent has no solute, but in solutions there will be solute. So that means there are solute particles. So the more the solute particles are there, the less the vapor pressure. That means now vapor pressure, or the pressure that is as a result of gases molecules on that bottle, it will be what? It will be less. Okay, we have here just some examples. Which of the following has more effect in vapor pressure? That means can reduce it more, knowing that all the quantities are 1 mole per each. Okay, look here now. Here now, we have a solution. And this solution now, it has NaCl here. NaCl. This one now, NaCl, when we have these ones now dissolved into ions, it's going to be Na plus and Cl what? Negative. So these ones now here, we'll have here, when this one is dissolved, we'll get 2 ions. 2 ions of solute inside what? Inside the whole solution. Okay, the same here, we'll have two ions. The same here, we'll have two ions. But here, this one now, AlCl3, when it gets dissolved, how many ions we'll have? We'll get Al positive 3, and we're going to get Cl negative, and Cl negative, and Cl negative. So that means we'll have now 4 molecules. You see? 4 molecules. So these ones now 4 molecules. That means 1 mole. 1 mole of AlCl3 will give us 4 moles of what? 4 moles of molecules. But here now 1 mole of NaCl will give us just what? 2 moles of molecules. And here 2 moles of molecules. And here 2 moles of what? Of molecules. So 1 mole of these compounds, these 3 compounds, will give us 2 moles of its components, which is Na and Cl. But here it's going to be into 4 ions. So we'll get 4 moles of ions. So 4 more ions here, 4 moles of ions. That means higher number of molecules that are solute inside the solution. And you understand that the more solute particles, the less the pressure, the less the vapor pressure. So that means in this case now, which of these 4 will reduce the vapor pressure more is the one that will have more ions produced. So that means AlCl3 is the answer. So you understand now what are colligative properties mainly. We said vapor pressure will decrease and boiling pressure will increase and freezing pressure will decrease. And we said we will have also what? Osmotic pressure. Okay, what is osmotic pressure here? Okay, here, for example, we have container of water and we have here container of water. Okay, if we put here permeable border and here we put what? Permeable border. Okay, what will happen if here, as we said, here is water and here is what? Water. In this case now, if the 2 sides are water, water will one of the sides try to make pressure in order to go to the other side? No, they remain in their places as they are. But here, if we put here just water, and it is pure water, that means pure solvent. And here now we put water, but we add to it what? Sugar. We add to it what? Sugar. In this case, we'll have the 2 sides now here. Will they remain in their places, or one of the sides will try to go to the other side? What will happen here? This is now we call it osmotic pressure. Osmotic pressure here in pure solvent, there is no what? No osmotic pressure. But here now we'll have osmotic pressure, or we call it osmosis property. Okay, in this case, what will happen? Will the sugar molecules try to go to the pure water, or the pure water will go to the... Okay, what will happen exactly? Look and concentrate there. Water molecules here has less concentration of sugar. So let me say they have 0 concentration of sugar. 0 concentration of sugar means 0 concentration of solute. So in this case, the molecules of water will try to go what? They try to take a pressure in order to go to the other side, to the higher concentrated solution. But higher concentrated by what? Higher concentrated by the solute particles. Okay, pay attention to understand this point is. This part now, it has higher concentration of sugar. Of what? Of sugar. But less concentration of what? Of water. Here now is the opposite. We have less concentration of sugar, but higher concentration of what? Of water. So that means left side, higher concentration of water, that means higher concentration of solvent, and less concentration by what? By sugar. On the right side, higher concentration related to sugar, which is solute, but less concentration of water, which is what? Solvent. So in general, in this case, water molecules, which are the solvent molecules, will move from less concentrated solute particles to the higher concentrated solute particles. So that means they'll go from left to right to where? to higher concentrated solute particles. So that means if we are talking about the movement of solvent particles, they'll go from, and we are using solute as indication, we're going to say that they move from less concentrated solute particles to higher solute concentrated particles. But if we are talking about the solvents, so you're going to say solvent particles, they'll move from higher solvent particles to lower solvent particles. So if you are talking about a solvent, from higher to lower solvent. But if you are talking about solute, they move from lower to higher solute particles. And the movement in general, it is the movement of solvent particles. We are not mentioning movement of solute particles. No, the movement in general in both cases is the movement of what? Of solvent particles. I hope that is clear now. So we understand now osmotic pressure, property, osmotic property. We understand vapor pressure property and boiling point property and freezing point what property. Just to add more ideas. The change in temperature, which is boiling point now, it will increase. In solutions, it will increase. How can we get the change in temperature increase? It equals the constant, which is boiling point depression constant times molality. And we understand molality that it equals how many moles of solute in 1 kilogram of solvent. So this one now you multiply them just to find this one. And also the change in temperature for freezing point, it's going to be a constant also freezing, and here for boiling, freezing times what? Times molality. Okay, now last point, we're going to say that in some cities where there are ice on the roads, they use salt in order for that ice to be melt. Why do they use that? And is it related to colligative properties? Is it one of the applications how we use colligative properties in real life? Okay, you're going to see. Okay, for example, we have a city. Name it City M. City M. M. Just a name of a city is M. The temperature at this city is -5 Celsius. Okay, this city now has snow. Has what? Has snow. Has snow on it. I'm using random numbers just to show you how it works, but the numbers are less than that. Okay, if we said if the temperature now is -5 Celsius. Okay, when we have in this case, when we have snow, if there is rain, will we have snow here on the roads? Yes. So this city will have snow. Why? Because water get freezed at 0 Celsius. And now the temperature at this city is -5 Celsius. So that means we'll have snow on the what? On the roads. Why? Because the snow get freezed at exactly what? 0 Celsius in general. Okay, what we do now, this one here, pay attention. Now this snow here, look, this snow here, it's pure. That means it's not solution. It's just snow. That means H2 or water only. Okay, now, if we add salt to this snow, what will happen when we add salt? So this snow now will no longer be solvent. In this case, alone, it will not be no longer what? Pure solvent. It will be changed into what? Solution. So this one now will become what? Solution. Okay, in solution now, we understand the property of solution that its freezing point decreases. Okay, I'm saying, for example, and I'm saying just random numbers, and then real numbers are less than that numbers, but here just to make it clear. If now, this snow now, as a solution now, its freezing point, as we said, it will decrease. So that means, for example, it will decrease to -7 Celsius. When the snow freezing point decrease to -7. What does that mean? That means now the snow in this case, it needs a weather of -7 in order for the snow to remain as ice, as solid. It needs -7 Celsius around it. But in the city, there is only -5. So that means in this case, the snow will not continue to be what? Solid. It will transform to be what? Liquid. So in this case, now the snow is melt on the roads. So when it is melt, when we add salt, that means we change the snow to be solution. And the solution now, one of its properties, its freezing point will decrease. When it decreases now to be less than the city temperature, that means the snow will be what? Will be transformed into what? Liquid, since it needs less temperature in order to keep being solid. Okay, what about if it decreases, if the snow here, if it decreases to to 3 Celsius, to -3 Celsius. If it just, the snow now decreased into 3 Celsius, its freezing point, while the city is still -5, so the snow will remain snow, it will remain solid. That's why not all the ice can be melted, because even if you add salt and the freezing point will decrease, the weather is still less than that amount, so that means it will keep being what? Solid. So you understand, in some cases only, the snow can be melted if and only if the weather or the temperature around it is higher than its freezing point after it gets depressed. Okay, I hope now we understand how we use colligative properties, and we understand colligative properties means what are the properties of solutions compared to their pure solvent, and we mentioned the 4 that are related, and we mentioned what is related to solubility and how we increase it. Thank you so much for this one. Then you can solve now the questions that are related.